Good morning, students. Welcome to the class. Let's start chapter number 6, that is weather and climate. Yesterday we have discussed about the introduction of this chapter. Let's continue weather and climate.
Number 6. Weather and climate. Weather always attracts the attention of human beings. For thousands of years, weather was observed by them and they also tried to predict it. But their knowledge about the weather was not systematic at all. Climate and weather are two different terms. They cannot be interchanged. The state of atmosphere at the specific time at any one particular place is weather. It combines wind, rainfall, temperature and pressure conditions of a small area for a very short period of time. It may change from day to day or even within the same day. Climate is explained as the average weather condition over a long period of time. It may be 35 to 40 years. The elements like pressure, wind, temperature, humidity and rainfall are taken into consideration. Temperature of the atmosphere. Temperature is the degree of hotness and coldness of the air.
So, as in this video, you will see that weather it's just a day-to-day condition of that day. Climate is an aggregate of weather when we consider it for next 35 to 40 years. Okay, if the same weather persists for next 35 to 40 years, then we can consider that area weather as climate. Okay, a day-to-day condition comes under weather. For example, today's weather is very sunny, but overall you will find that the season in which we live is a winter season and the climate is a winter climate.
The temperature of atmosphere changes not only between day and night, but also from season to season. Summer is hotter than winter. Solar radiation is the heat which we receive on Earth's surface. It is also termed as insolation.
So the all the sun energy coming from the sun which reaches the earth's surface, it is called as insolation. Insolation. Okay, very important.
The Earth does not receive same amount of heat everywhere. Near the equator, the amount of heat is maximum. And as we start moving away from the equator, due to this phenomenon, three distinct heat zones are created on the surface of Earth. Torrid zone. It lies between the Tropic of Cancer and the Tropic of Capricorn, 23.5 degree north and 23.5 degree south respectively. This is the hottest part of the Earth. In this particular area, the rays of the sun fall vertically on a small portion, resulting in concentrated heat. Temperate zone. The location of North Temperate Zone is between the Tropic of Cancer, 23.5 degree north, and the Arctic Circle, 66.5 degree north. The location of South Temperate Zone is between the Tropic of Capricorn, that is 23.5 degree south, and the Antarctic Circle, that is 66.5 degree south. These zones have moderate temperature than Torrid Zone. Frigid Zone. The location of the North Frigid Zone is in between the Arctic Circle and the North Pole, 90 degree north. The location of the South Frigid Zone is between the Antarctic Circle and the South Pole, 90 degree south.
So as we know that sun rays have different angle of inclinations when it reaches to the surface of Earth. So every part of the planet does not receive same amount of heat from the sun. On the basis of heat received on the Earth is divided into three parts, that is torrid zone. Okay, torrid zone is a zone between Tropic of Cancer, okay, and Tropic of Capricorn. So this area, okay, this area between Tropic of Cancer, equators and Tropic of Capricorn, that area is called as torrid zone. So all the countries lie in between this area will have more heat as compared to other parts of the world. Okay. Second zone is called as temperate zone. Temperate zone is a zone between Tropic of Cancer and the Arctic Circle. So this area receive inclined sun rays, so it will be more cold than the torrid areas. Temperate zone is also divided into North Temperate Zone and South Temperate Zone. So the area between the Antarctic Circle and the Tropic of Capricorn, that is called as the South Temperate Zone. Last but not the least is frigid zone, the colder region of the world, generally the pole region, North Pole and South Pole region. Area starting from the North Pole to the Arctic Circle. This area receive very less sun rays, and that is the reason you will find many continents in this area will have 24/7 365 days ice covered. Okay, frigid zone important.
This area is very cold because it receives the slanting rays of the sun. These rays travel long distance spread over a large extent. For most part of the year, the polar region remains almost frozen. Measurement of temperature. Thermometer is the instrument which is used to measure temperature. It can measure the temperature of free-moving air. The two most common temperature scales are Celsius and Fahrenheit.
So degree of hotness, we know that that is called as temperature, and thermometer is the instruments used for measuring that. Now there are different units of temperature, Celsius and Fahrenheit. We generally measure the body temperature in Celsius and Fahrenheit. There is one more unit called as Kelvin, that is the SI unit of the temperature. It is not in your syllabus, but for your additional information, Kelvin is the SI unit, standard unit of temperature.
Range of temperature is the term used for difference between the maximum and minimum temperatures. Heating of the atmosphere. The heating of atmosphere is quite different. It does not get heated directly by the rays of the sun. Very little solar radiation is absorbed by the atmosphere, which passes through different layers of the air. First of all, sun's rays heat up the surface of the earth. The contact of the air with the heated surface of the earth warms up the lower layers of the atmosphere. Atmospheric pressure.
So till now we thought that the sun rays coming from the universe to the earth, it generally reaches the surface of earth by heating the atmosphere till it reaches the surface. But this is not the case. First, the sun rays heats up the surface of the earth, and after the heating of the surface of the earth, that means land ultimately heat back the upper layers near to the surface of earth. Okay, so this is very much important. Earth's surface heat backs the atmosphere of the planet.
Air contains weight and it creates pressure on the surface of the earth. In other words, the force exerted by a column of air due to its weight at a particular place on the earth's surface is called atmospheric pressure.
Atmospheric pressure, you have already learned this from chapter in class 6 or even in class 7 science chapters. Atmospheric pressure, so pressure
The
generally
instrument
feels
which
in
is
the atmosphere. Okay, and the instruments used for this to measure the atmospheric pressure is called as barometer. Okay,
used to measure atmospheric pressure is called a barometer. There are two types of barometers, mercury barometer and aneroid barometer. The unit in which atmospheric pressure is measured is called millibar or MB. Wonderful to know, the air above us presses us with a great force on our bodies, but we don't even feel it. The reason is that the air presses us from all directions and our body exerts a counter pressure. Factors affecting atmospheric pressure. Atmospheric pressure on the Earth's surface is not uniform and varies from place to place. The following factors affect atmospheric pressure. Temperature. When the temperature increases, the air expands and its density decreases. Due to this, the air becomes lighter and exerts less pressure.
So the first, there are some factors which affects the atmospheric pressure. One of that is temperature. So when temperature increases, air expand, means it take a great shape, and density decreases, ultimately resulting into the less weight, or the air so much light that it rises up, okay, in the atmosphere.
On the other hand, cold air is dense and heavier, so it exerts more pressure. The areas close to the equator generally have lower pressure. Altitude. The air pressure is highest at average sea level and decreases with the increasing altitude. As
Second point is altitude. Air pressure is highest, okay, at the average sea level, but it decreases with the increasing the altitude. Altitude means height. So with an increase in the height, there is a decrease in atmospheric pressure. That's why you will find that all the fighter pilots, okay, they wear a gravity suits to counter this atmospheric pressure, their effect on their body.
as we go up, the density of air decreases, and so does the pressure exerted by it. Water vapor. The air containing more water vapor is lighter than the air which has a little or no water vapor. It is because of water molecules. They have less mass than other gas molecules of air. So, as water vapor increases, the density decreases. Therefore, moist air exerts less pressure than dry air. Pressure belts. According
So the next topic is pressure belt. What are pressure belt? We will discuss in this different pressure belts on the globe, and the how pressure belts results in the different wind formation on the globe.
to the temperature, the horizontal distribution of atmospheric pressure varies from place to place. There are four major pressure belts on the Earth. These are equatorial low pressure belt. It lies around the equator. As it is the hottest region, the air heats up quickly and becomes lighter on expanding. It is also known as doldrums. In this belt, there is no surface wind. Subtropical high pressure belts. These belts of high pressure lie near 30° north and 30° south latitudes. This belt is also called horse latitudes. The high temperature in the equatorial region starts decreasing in these belts after losing its heat. Subpolar low pressure belts. These belts exist near 50° north and 70° south latitudes. The warm air rises, creating a strong upward current. This upward current pulls the cold polar air down. This creates belts of low pressure. Polar high pressure belts. These belts lie in the extremely cold region of the North Pole and the South Pole. In these regions, the air is very heavy and is not able to leave the surface. Thus, the weight of cold air creates these belts. Pole and the South Pole. In these regions, the air is very heavy and is not able to leave the surface. Thus, the weight of cold air creates these belts.
So there are four different kinds of pressure belts which I want to tell you here is that with the help of this diagram we can easily understand.
Creates belts of low.
See, this area, that is the equator area, near to the equator areas, near to the equator areas. Okay, this is a equatorial low pressure belt. Then this area is the high pressure belt. Again, there is a low pressure belt and at the pole high pressure belt. So you should remember from equator side low, high, low, high. It will be a shortcut for you to remember the pressure belt. So pressure belt means in which the atmospheric pressure, the wind formations, it all depends upon this system. Why? Because we know that wind blow from high pressure to low pressure. Okay, and this pressure belt results in the different kinds of wind formations, which ultimately leads to the weather and the climate of that globe. Okay, so we will continue from here.
Low pressure. Polar high pressure belts. These belts leave the surface, thus pressure area heavy and is not able to leave the surface. Thus, the weight of cold air creates these belts. Planetary wind system.
So planetary wind systems in next part.